Hi everyone, welcome back to Food for Thought. Today we're going to be talking about solubility and precipitation reactions. So solubility is the ability to break up or dissociate into ions. So, for instance, if you have something like sodium chloride, this is going to break up into Na plus and Cl minus. So those are its component ions. Now, not all ions are just one atom. We have what's called polyatomic ions, that's Greek for many ions, many atoms. So we have things like SO4, which has a charge of -2, PO4, which has a charge of -3, and carbonate ion, which is going to be also -2. These are all common ions that you guys should know. And now there are certain rules that dictate whether a certain cation and anion combination is going to be soluble. And if you remember, we said that a cation is a positive ion, and an anion is a negative ion. So we combine those two to make a molecule, and here are some rules dictating whether it will be soluble, and these are all in water. Not all solvents dissolve the same way. So you'll note that all nitrates are soluble, all acetates are soluble, all halogen ions are soluble, except for the ones that I've listed. Same with all sulfates. Carbonates and phosphates are virtually all insoluble, except for the exceptions that I've listed. Same with hydroxides and sulfides. And then virtually all compounds with Na+, K+, and NH4+ are all soluble. Now we bring back the idea of the solvent, which is the substance available in a greater amount in a mixture. And the solute is available in a lesser amount. So this is basically the thing doing the dissolving, whereas the solvent is going to be the thing getting dissolved. Now we're going to look at some examples, which include the example we looked at last time. So we're going to have AgNO3. Again, the aqueous means that it's in water. Again, anything that's aqueous dissolves in water. So if you look at the chart we just saw before, silver chloride is not soluble, so that's why the AgCl precipitates. And then we can look at some other examples, like this is sort of an acid-base reaction as well. Since Hi is an acid and zinc nitrate is a base, note that nothing precipitates here because zinc iodide is soluble in water. And hydrogen nitrate, also known as nitrous acid, is also soluble. And finally, we have calcium chloride and sodium phosphate, which is, again, soluble in water because sodium is an exception to the rule. And we have a precipitate here. Now, some of the theory behind these solubility rules is a little complex. but it has to do with what are called intermolecular forces. Molecules don't just exist on their own. There are lots of other molecules around them. So we have to think about how each molecule acts when it's around other molecules. So things like water, which are polar, have little bits of extra electrons around the oxygen. So when they come near another water molecule, these little deltas with the plus and minus just means that there's a little teeny bit of charge there, which you'll learn more about in your organic chemistry class or even a calculus class. So the positive charge from the hydrogen will be attracted to the negative charge on the oxygen. And this is what's called a hydrogen bond. It's not a real bond, but it's a pretty strong intermolecular force. It's actually the strongest of the intermolecular forces. There's also what are called dipole-dipole interactions. So a hydrogen bond can only happen when a hydrogen is bonded to fluorine, oxygen, or nitrogen. Every other polar molecule will have just dipole-dipole interactions, even ionic ones. So we've got NaCl. The Cl has the minus charge, the Na has the plus charge. If we have another NaCl with, again, the same plus and minus, the Na will be attracted to the Cl because it's positive and the Cl is negative. So this is what we call dipole-dipole. And then we finally have London dispersion forces, or LDF, which are only in nonpolar molecules. And these are just caused by the way the charge is distributed temporarily in the molecules. When it comes to solubility, there's an old adage that says like dissolves like. So look for similar intermolecular forces. If you look for similar intermolecular forces, you'll be a lot more able to find what is soluble with what. Good luck, and we'll see you next time to talk about redox reactions.